And already we can see that just doing it underwater is not going to be, just doing it all underwater is not going to be an effective, cost-effective method. Well, we can gauge that it's probably going to be something in between these two, a combination. Now, it might be that this is the shortest route, but it could be that it's going to be a combination of the two. So say going from point P to some point here, and then going the rest of the way all the way to Q. And let's call this point S. Well, I'm going to define that the distance between the shortest distance underwater, T, to whatever this other theoretical S is that could move wherever, is going to be the length of X, which means that the rest of this distance is going to be that 1200 minus whatever that X is. And this is going to give me option 3. Some underwater and the rest underground. So we're going to combine going from P to S with S to Q. For this, we're going to state that X is going to equal the distance between T and S. Now, it could be that straight to T is the shortest distance, which would make X actually equal to 0. We already know that it's not going to be the longest distance for X, which would be the full 1200. But we're probably going to include that as a possibility. X can be anywhere in between or up to these points. And we're going to say that C, which we've already been using, is the cost in dollars. And logically speaking, the cost is going to be greater than 0. So we're going to say that our minimum cost is going to be the length of P to S times $80 per meter, and the length of S to Q times $40 per meter. Now, the length of P to S is going to be based on this right triangle right here, where it's going to be the hypotenuse of that right triangle. So one side of it's going to be X, the other side of it's going to be 100. So we're going to call that length the square root of X squared plus 100 squared. And the length of S to Q we already defined as 1200 minus X. and we're going to be multiplying that by 40. Which means that we're going to be taking 80 and x squared plus 100 squared to the power of 1/2. I'm going to combine that with 48,000 minus 40x. It's already in one variable, so I can just go straight to deriving it. Can skip over step 4, turning it into one variable, and I'm going to go right to step 5. And I'm going to derive this and take c prime of x. Well, the first one is going to be the chain rule. 40 x squared plus 100 squared to the power of 1/2 multiplied by the derivative of the inside, 2x. That 4800 is just going to be plus 0, and then the negative 40x is going to be minus 40. Which means that this is going to give me, and it's negative 1/2. This is going to give me the 40 times 2x is going to give me 80x. And I'm going to move this down to the denominator and get the square root of x squared plus 100 squared minus 40. I'm going to combine those two terms by multiplying the 40 by square root of x squared plus 100 squared over square root of x squared plus 100 squared, so that I can actually combine these. And I'm going to wind up with c prime of x is equal to 80x minus 40, the square root of x squared plus 100 squared, all divided by the square root of x squared plus 100 squared. Now I'm going to be doing my critical numbers. I'm going to pull from the numerator. And if I have 80x minus 40 and the square root of x squared plus 100 squared is equal to 0, then the first thing I'm going to do is I'm going to move that radical over. 80x is equal to 40 and the square root of x squared plus 100 squared. I'm going to divide both sides by 40, and I'm going to get 2x is equal to the square root of x squared plus 100 squared. I'm going to square both sides. And I'm going to get 4x squared is equal to x squared plus 100 squared, or 3x squared, when I move that over, is equal to 100 squared is 10,000. And x is going to equal, I'm going to divide by 3 and square root it, the square root of 100,000 over 3, or 100 root 3 over 3. The denominator is going to be the square root of x squared plus 100 squared is equal to 0. So x squared plus 100 squared is equal to 0. X squared is going to equal negative 100 squared. And we know that this is not possible. So then I'm going to do my first derivative test. And I'm going to know that it's going to be between 0, 100 root 3 over 3, and 1200. So I'm going to pick 1 and 100 to be my test numbers. And I'm going to see that c prime of x is going to be negative, and that's going to be positive, which means that my c of x is going to be decreasing, and it's going to be increasing, and there is my minimum that I'm looking for. I'm going to put this back into the cost formula that I simplified, and I'm going to say that the cost is going to equal 80 and the square root of 100 root 3 over 3 squared plus 10,000. And I'm going to combine that with 40 times 1,200 minus square root of, 100 root 3 over 3. I'm going to put it on my calculator, and I'm going to wind up with a cost of $54,928.20, which is in fact my least expensive option. So when it says, what is the least expensive way to lay the cable? It's going to go from Q to S, and P to S.